at time t, should n of t be closer to k or farther away? So if there's no crowding going on, then n of t is going to be further away from the carrying capacity, right? And since n of t is further away from k, then we expect this term here, n of t over k, so if they're farther apart, then that's going to be close to 0, okay? Because there's a big distance between those. numbers. So if this is getting closer and closer to 0, then 1 minus this is getting closer and closer to 1. So basically, if we think of it as just this model, well, do you remember when we solved this back in the separable? We solved, I think it was, I can't remember if it was a 5 or what the number was. I can find it later if you want. But when we did this, we got an exponential answer, right? E was in our answer. So it's going to grow exponentially, right? An exponential function grows exponentially. So that means that it will be growing exponentially according to this model. Now, what about if there is crowding? Okay, so if there is crowding, should n of t be closer or further away? Well, if there's crowding, right, then there's not enough resources. So the number here of, whatever the species is going to be close to k, but still less than k. So, we have too many animals. So it's the number of animals is really, really close to what the carrying capacity is for that land, okay? So that means that this is really close to 1. So then if this is, getting to 1 minus 1, basically, right? If we say this is close to 1, then this whole thing is getting closer to 0. And then 0 times this is going to just be getting closer and closer to 0. So it's growing, but very, very, very slowly, right? Right? Because it's just really small. Okay. And what if there's just way too many animals for the land to support? So if there's overcrowding, then we expect the number of animals is well over what the land can support, right? So we're greater than the carrying capacity now. And so what that means is that n is larger than k, then maybe, this factor is 2 or, 3 or whatever. But 1 minus 2 or 1 minus 3 or whatever it is definitely going to be a negative. So if this whole thing is negative, then we know that because n is a positive number of animals and r is a positive constant, then we've got positive times negative, which is going to be a negative. And so now the population is not going to be growing at all, right? Animals are going to be dying because they don't have enough food. They don't have shelter. They're all, fighting for their life over the same resources. Okay. And if they ask you which part of the logistic equation is going to tell you about crowding, you can either say the n of t over k or the whole bracket, 1 minus n of t over k. So, either would be fine because they're both kind of looking at what the effect is. So, okay. So, typical question, give you a graph. A lot of times it would just be a multiple choice. Don't think I've ever seen one of these as a long answer. I don't think so. Certainly if they did ask it as a long answer, it would have to have a lot of parts, right? But, maybe they ask, where is it increasing, decreasing, what's the equation, or ask you a bunch of where it tends towards, okay? So I want you to take a look at the graph. I want you to think about what I said about above the horizontal or below the horizontal and which way your arrows are. And in C, I want you to tell me what's the equilibrium values. So see how far you can get on A, B, and C, okay, from your graph here. And then we'll take it up and talk about D. Okay, so my equilibrium, I've got 1 at 0, 1 at 12, 1 at 18, it looks like. So I can do that first. Okay, so now this is above the horizontal, so that's to the right, and that's to the right. Okay, and then so below here is left, and here is left. Okay, so at 0, we have the arrows pointing away from each other. And at 12, and then we have 18 down here. Okay, so at 0, away from each other, so we have unstable. And 18 as well is also arrows away from each other, unstable. And at 12, arrows are towards each other, so stable. So stable, unstable, unstable. Okay. Where is the graph increasing and where is it decreasing? So increasing would be above the horizontal. So this would be increasing and this would be increasing. So increasing or above the horizontal would be from 0 to 12, or also from 18 on to infinity. And below the horizontal would be the decreasing. So I would say decreasing below the horizontal would be from, I guess we'd say from negative infinity back to 0, or also below, so from 12 to 18. Now, in terms of writing your equation, you have to be careful because, you know, we do know that it's y minus each equilibrium, right? Think about when we factored things, equations. So we know it's like y minus 0, y minus 12, and y minus 18. And we know it's a cubic, right? It has the cubic shape. So we've got our 3 equilibriums. But what you want to make sure of on the exam, just in case they try and mess with you, make sure you know, would this be a positive out in front or a negative, right? So once you write your equation, do a test point and make sure. Because if it's supposed to have a negative in front, then you might have the total wrong equation for your graph, right? So for instance, like if I put in, obviously you can't check an equilibrium because it would just give you 0. But if you put in something, you know, here, like maybe this is 6, right? If I put in a number like 6 into here, well, then I've got 6 minus 0, positive, 6 minus 12, negative, 6 minus 18, negative. So positive, negative, negative is positive. And yes, it is above the horizontal. So just check a test point to make sure that it is a positive out in front of there. There's no negative sign, okay? Because there's 2 possibilities, right, with the same equilibrium. Now, if you remember that a positive cubic goes in the shape, then you don't have to check that. But in case it's a harder one, you might want to, okay? And of course, we wouldn't write the y minus 0 in the final answer. We just write y. Okay. So given the following initial conditions, what will the value of y tend towards? In other words, you know, what is the limit as t approaches infinity of y of t, right? That's what we're asking it. Okay. So they can either say this or they can, you know, say it like that. Okay. So y of 0 is 2. So it doesn't really matter what they give you here. It's this that we want to go to. So we're always going to start at the number that it equals. So we're going to start at 2 on our graph. Okay. So always start at these numbers here. even if they said y of negative 1 is 2 or whatever, okay? So if we start at 2, what do we do? Well, 2 is about here. So that's right there. So if that's where I am on the graph, follow your arrows. The arrows are pointing to the right. So it's going to keep going this way until it gets to an equilibrium. Once it gets to an equilibrium, it's always going to stop. So that means 2, it's just going to keep going until it gets to 12. So it's going to increase to 12. So in other words, the limit there is 12. Okay? Start at 10. Okay, so 10. Sorry about the moving up and down here. So 10 is like maybe here. That's our 10. So we're there on the graph. So it's still going increasing. So it's still going to increase to 12. So the limit is 12. What about at 15? If we start at 15, what are we looking at? Well, that's maybe somewhere in there, right? So take a look. What do you think it's going to do from 15? Is it going to increase? Is it going to decrease? What's it going to end up as? What's the limit going to be here? Well, if it's right here and you follow your arrows are telling you that you're going to go this way, right? And you're going to keep going that way to the left until you get to an equilibrium. And the next equilibrium to the left of 15 would be 12. So it's going to decrease back down to 12. So we could say, the limit as t approaches infinity of y of t would be 12. If we start with y of 0 is 15. Okay, what about at 18? What would happen at 18? Well, 18 is an equilibrium. And if you're at any equilibrium, stable or unstable, it just stays there. So it's going to stay at 18 because it is an equilibrium. Okay, last one, 22. If you start at 22, what's going to happen here? Start at 22. So 22 is way up here, right? Somewhere over. But your arrows are going to the right. So guess what? We're actually just going this way. And there's no more equilibriums. It's just going to go up, 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 up forever, right? So it's going to increase to infinity. So i.e. the limit of this one would just be infinity. Okay. Any questions? Okay, well, awesome job. So come back at 11:45 and we'll continue on, okay? Have a great break. Be back soon. Welcome back, everybody. I hope you're doing well and you had a good break. So we're just going to continue on. We're going to finish off this section, then work on probability, okay? All right, and don't forget all your solutions in your account. And I will show you the supplement, just to remind you of that in case you were away yesterday, okay? So the supplement is looks like this, okay? So those are all the midterms, and there's some older ones from 2021, but all those questions will still apply that are in here, okay? Okay, so turn to page 102, and I want you to, they've said that the equilibrium is 0. I want you to classify it. So go ahead and do your chart and do a test point and see what you come up with. Okay, so this particular question was a multiple choice. So we have 0 there. Let's just test, something above 0. May as well just do 1. It's easy. And then -1. So we've got that, this is our g of t. And so we can test 1 is my u here. So we've got, 1 to the 5, which is 1, which is positive, and -1 to the 5 is negative. So this is to the left, and this is to the right. So this would be unstable at 0. You could also just do the derivative, right? You could say we've got u to the 5. So the derivative would be 5u to the 4. And in this case, it wouldn't work, right? Because if we do 5 times 0 to the 4, we get 0, and so it's inconclusive. So the second method actually just doesn't work in this question, okay? And if you had to find the equilibrium on your own, then you would just set, to find the equilibrium, if they didn't give it to you, then you would set this equal to 0, which I know is kind of weird. But basically, what to the 5 would give you 0. The only answer would be 0, of course, right? Okay. Okay, and the last one here, consider the family of functions, plot y prime equals g of y, and classify the equilibrium. So this one was a multiple choice, and they gave them, I think, 4 or 5 graphs that they had to pick from. And they just said which one is the correct graph. And there was actually 2 that looked the same on the exam. So first thing, see how this is going out and then out this way from 3? And then, so this right here, that's an equilibrium. And then see how it's going towards this and towards this. So this right here is another equilibrium. Okay. So first of all, what would the graph look like if this is, y and x here? Well, this is like we want the y prime in the y graph, right? So let me just draw a little spot for a graph here. Or you could call it y and dy. by dt, that's fine too, right? So, but we know that we need an equilibrium at -1 and 3. So we're trying to figure out what did the graph look like, right? So it would be -1 and then 1, 2, 3. That's where it would cross. And then you've got to figure out, what does the graph look like, right? Well, let's see. This is above 3, right? So above 3, so in other words, greater than 3, what's happening, right? Well, these are going up and to the right, right? They're increasing. So these are going up and right. So i.e. increasing. So above 3, increasing. Now, what's going on in this region between -1 and 3? Well, see what we're getting here, right? This is going down and right, so this is decreasing. Okay. So that's going to be below the horizontal axis, whereas increasing is going to be above, right? A horizontal. So this is below, so like this. And then we have one more spot down here, which is below -1, so in here. So below -1, so in this portion of the graph, it's going up and right again, so it's increasing again. And so again, it's going to be above the horizontal. Now, remember I said, well, there was 2 graphs that looked the same, so how did they know which one to pick? Well, they had 2 that had this shape, but one of them was perfectly symmetrical about this y prime axis. Well, it can't be perfectly symmetrical because 3 should be further over to the right than -1 is to the left, right? So it wouldn't be right to pick the graph that looked, like this, right? That it was perfectly symmetrical. That's not the same thing, okay? So that's not right, okay? Because we know that it's -1 and 3, okay? All right, so you've got questions to try in F of every type. So again, on the ones where there's, like I like to say, kind of no numbers, then if you want to do the derivative method, that might work better for you. Okay. So after you get done that, you can also look at the quizzes. So quiz 2 has, questions on population, salt, IV, all of that. It's got Bernoulli questions. It's got equilibrium questions and limits and all of that. Okay, so lots of good practice there. And then the practice exam is on page 108, and that has everything from A up to, what did I call that section there? I think it was it J, guys? Yeah, I think it was J. So this would be sections A to J. So in other words, everything that's on your midterm except for no probability yet, okay? So again, you can practice your recursive, short way, long way, all kinds of questions on there, okay? So we're gonna move to probability now. So probability is on page 111. And again, if you weren't here yesterday, I did mention that you don't have to know sensitivity, specificity, and type 1 and 2 errors because you didn't cover it up in week 6. So I'm guessing you're gonna do it this week, but it's not on your midterm. So it'll be on your final. Okay, so basic probability. Basic does not mean easy, so don't think I'm saying it's easy. It's basic probability means no conditional yet. So conditional is like an extra formula, which tends to be, trickier. So That's why we call it basic versus conditional. Okay? So an outcome of an experiment is a possible observation when you perform the experiment. So for example, when you roll a die, one outcome is getting a 1, right? So that's an outcome. We can have an event as like a collection of outcomes. So for example, if I roll a die and I say, let's get an even number, 2, 4, 6. If I say, let's get a number that's divisible by 5, right? Then I would just be the number 5, etc., right? If it's called a simple event, it can't be broken down further, okay? So, like rolling a 1, I can't break that down further, but rolling an even number I can, right? Because it's 3 different possibilities. The sample space is the complete set of all the possibilities. So of course, we've all rolled a die. We know the sample space is 1 to 6. I'm used to S, but you guys use omega for sample space, so I always try and remember to write that instead. So for example, if I flip a coin twice, and E is the event that you get at least one head, then these are all the cases in the sample space, right? So the sample space would be get tail, tail, head, head, or tail, head, head, tail. These middle two are different because the order matters, right? First flip versus second flip. If we want to get at least one head, then we would only not have that case because the rest of these would have at least one head. Now, a Venn diagram is an example of a visual. So you guys did do set notation, and I'll do an example specifically with some hard set notation at the end. But, if you are a visual person, a lot of people like to draw a Venn diagram and kind of figure things out based on that. So for example, like if I have, this is 0.4, this is 0.3, and this is 0.2. These two circles represent what's in E and what's in F. So what's in the middle here, that would be the probability of being in E and F. The and symbol looks kind of like an N. It's called the intersection symbol. The or symbol is what we call the union symbol. If you take 1228, they have so many words for it. But what it means is that you can be in E or F or both. So you have to be careful with the or in the math world and the or in our English language, because most people think that if someone says you're taking applied math or chemistry, most people would think they're taking one or the other, but not both. But in the math symbols, if we want the union of math, union, chemistry, then we think math or chemistry, or they can be in both, okay? So in other words, the union is this, and this, okay? Now, when you're missing some number, there's 1, 2, 3, 4 places. So we can just do 1 minus all of the others to get the missing, because probabilities have to add up to 1 in every experiment. And so now we would know that the probability of being in both is 0.1. So in the union here, we would have 0.4 plus 0.1 plus 0.3. In other words, everything except the 0.2 on the outside. Okay. So what else can we talk about? Well, this sort of a moon shaped here, this is the probability of being in E and not in F. Okay, so it's in E and not in F. And to not be in something is, we use this complement, this C. So we say E and not F, okay? So F complement means you're not in F, okay? So this sort of moon-shaped over here would be probability of being in F and not in E. And so that would be 0.3. And the last place to sort of think about is this 0.2. And it's the outside, which means it's not in E and it's also not in F. So in other words, it's not in either of them, okay? So we call that E complement and F complement, because that means it's not in either, right? Not in either. and that would be 0.2. Okay, so those are all of the places that you can get. And, we will do tons and tons of solving. And then, of course, we'll have the formula as well. Okay. Any questions so far? Now, if you have to take probability again ever in your life, you might see that you have other symbols for being not in something. So those all mean the same thing. They all mean not in A. So sometimes in different courses, you might see a prime used or a bar used, and that's, it's the same thing. Yeah, so the probability of E, yeah, good work. So the probability of E here would be the entire circle. And so the probability of being in E would be 0.4 plus 0.1 is 0.5. That's correct. And alternatively, the probability of being in F here would be the whole circle of F. So that would be 0.1 plus 0.3. And so, oops, can't write an F. Probability of being in F would be 0.1 plus 0.3 or 0.4. That's correct. Good work. Okay. Any other questions? Okay, so here is how we can find the union. We could just add up the numbers, but we also have a formula. And the union formula you guys called inclusion exclusion. That's definitely the most complicated way I've seen them ever mention it. But anyway, that's what you called it. Union's probably simpler for you. So that's everything in A or B or both. Now, so we had that picture. Let me just do the one that we had here. So we had the union was 0.8. So we had 0.4, 0.1, 0.3. Now, I already found, the probability of both a second ago, just because someone asked me. But here we're going to talk about it again because I wanted to show you the formula. So if we want A union B, we'd have, probability of A plus probability of B minus probability of A and B. Works the same way for E union F. So if I wanted E union F, it'd be probability of E plus F minus E and F. So remember that, yes, if you want the union, you could just do this plus this plus this, which we did a minute ago. But we could also do the probability of being in one circle. So if we call this, let's say if this is E, just because I used that diagram last, then the probability of E, remember we said would be 0.5, the whole circle. And the probability of F would be all of this circle, which would be 0.4. And so if we use the formula, we would just say probability of E, pink circle, 0.5, plus probability of F, I call this E and F, orange circle, 0.4. But notice when I add the pink circle and the orange circle, I added the middle twice. So that's why we get minus the middle. And we still get the same answer we did on the last page if we just did this plus this plus this. So if I already had my picture, I'd never bother with this. But if I didn't have a picture and I just had these numbers, I could go straight to that formula, for instance. Okay? So kind of two options, right? Okay, and we talked about the middle. That's called the intersection. That's the and. And we talked about the complement, which is, of course, the probability of not being in A. So let's say, we said that the probability that it snows today is always snowing, right? 90%. Then the probability that it doesn't snow would be 1 minus that it does snow. And so we would say it would be 10%. So remember, probability just tells you how likely something is to occur. Okay? Okay, any questions? Trying to go slower through probability just because, you know, some people have a lot of trouble with it. We're good? Okay. So what is the sample space? So if they ask you what is the sample space, then we're looking at what is all the possibilities. So if we roll an ordinary die, then our sample space would be 1 to 6. And we can call that omega, right? Because on a die, we can roll a 1, 2, 3, 4, 5, or 6. Okay, what about if we roll a die twice? Well, rolling a die twice actually has 36 outcomes because it has 6 on the first and 6 on the second, and is always to multiply in math. So we have 36 possible outcomes or possibilities. Now, of course, they wouldn't make you write out all of them, but I put it here just to kind of show you what it looks like. You know, you can get a 1 first and then a 1, roll a 1 and then a 2, 1 and 3, all the way up to 1, 6. Then you get 2, 1, 2, 2, 2, 3 to 2, 6, and then all the way down to 6, 1 to 6, 6. So you can see you have 6 times 6, or 36 possibilities. If we want to flip a coin, what's it say, 3 times? Well then, you know, the best way to kind of visualize a coin is to probably draw a tree. So we can say on the first toss, we can get a head or a tail. On the second toss, from this head, we can get a head or a tail. Or down here from this tail, we can get a head or a tail. And then the third toss, same thing, heads or tails. So if you follow the tree through, that's head, head, head. Then we get head, head, tail. Then on this next branch, we get head, tail, head. And then head, tail, tail. And then if we go to the bottom, starting with tail, we get tail, head, head, tail, head, tail. And then the very, very bottom, we would get tail, tail, head, and tail, tail, tail. And so you can see that in total, you would have 8 outcomes, right? And that comes from 2 choices for the first and 2 choices for the second toss and 2 for the third. Okay, and it would be the same thing for having kids, right? Male, female, male, female, male, female. Okay, so that kind of thing. Okay, so this is 2 choices, heads or tails. Okay, so those are sample spaces. So there's a couple of sort of, you know, terminologies that come up quite a bit, so you should make sure you know them. So mutually exclusive, which is also called disjoint, versus independent. So mutually exclusive means they can't both happen at the same time. So look at my picture of my Venn diagram. Remember, there was typically a spot where A and B overlapped. We called it A and B. But for this one, there is no overlap. And so that means that when we have mutually exclusive events, that means that the probability of both A and B occurring is equal to 0, okay? So that's what you have to know every time you see mutually exclusive or disjoint, right? Because there is no overlap of those circles, okay? Now, independent is different. So make sure you don't mix them up because people will often say for independent, A and B is 0, and that's totally wrong because independent means they don't affect each other at all. So independent, you're going to write down for A and B that A and B is A times B. We get the product, okay? So A and B is 0, that's mutually exclusive, disjoint. A and B is A times B, that's independent. So sometimes they'll say, you know, the probability of you getting an A in chemistry is 80%. The probability of getting an A in applied math is 70%. So what's the probability of getting an A in both if they're independent? Well, then we would just do 0.8 times 0.7. Now, in terms of, real life examples, like let's say you think about playing cards. I'll show you the card deck in a minute if you don't play cards, but if you take a single card out of a deck, a single card can't be both a king and a queen, right? One card, it could be a king or a queen or neither, but it can't be both. That's an example of mutually exclusive or disjoint. The probability of getting both, one card that's both a king and a queen, is 0. It's impossible. Independent would be something like getting a king and getting a heart. King is a number of card and heart is a suit, and those don't affect each other. So we can get a king of hearts. We can get a king not of hearts. So that's independent, okay? And keep in mind that you can never have both at the same time. So we can have an experiment that's independent. We can have an experiment that's mutually exclusive. And well, most experiments are neither, but we can't get both. Because if we did have both, if A and B here is 0, and A and B is A times B, if they were equal, then A and B are the same. So that would mean that A times B would have to be 0. And assuming that A and B are not 0 probabilities, two non-zero numbers can never multiply to give you 0. Okay, so remember, you can have one or the other or neither, but not both. So this one here, this says, number of favorable events over number of total events. That's the formula for probability. So if I wanted, let's say, the probability that I rolled a 6 on a dice, then I can get 1 6 out of 6 numbers total. If I wanted the probability that you pull an ace out of a deck of cards, well, there's 4 aces in the deck out of 52 cards total in the deck. Okay, so that's what we're looking at for probability. Something on top, something on the bottom, and a fraction. Or a decimal if it's easy enough to do, but without a calculator, sometimes it's not, right? Okay, question. Okay. So suppose Emma rolls an ordinary die once. Okay, so she rolls a die. E is the event that it's an even number. F is that she rolls a 1, 2, 3, or 4. Okay, we want E union F, E intersect F, and E and not F. Are they mutually exclusive? So this means in E or F or both. And so, well, E is even number. So even is 2, 4, or 6. And F is right here, 1, 2, 3, 4. So if we want the or, the union, we just list everything in E and everything in F. Just don't list anything twice, okay? So F is 1, 2, 3, 4. And E is 2, 4, 6, but I already have the 2 and 4, so now we just need the 6. So the union would consist of everything except 5. Now, if we were asked for the probability of E union F, then that would be the number of numbers in here, which is 5 elements, over the total sample space. And remember, for one dice, we can get 6 different possibilities, right? That's called our sample space. So this is the number in the sample space, and this is the number in the union. In other words, there are 5 elements here. So if they ask for probability, it would be 5, 6. Okay, E and F. E and F. Well, that means it has to be in both. So take a look at E and take a look at F, and what's in both of them at the same time is what we want here. So 1 is not in both, 2 is in both, 3 is not in both, 4 is, and 6 is not. So that means in both is just the numbers 2 and 4. So can you write down for me what would be the probability of being in E and F then? probability of being in E and F. Well, it would be 2 elements out of 6, so we'd reduce that to 1/3. So this one says, what's in E and not F? In E and also not in F. In E and not in F. Okay, so E, let's write down E is 2, 4, 6. Now you can either just look at E and look at what isn't in F, or you can actually write the set F complement, which is things that aren't in F. So if F is 1, 2, 3, 4, F is 1, 2, 3, 4, then 5 and 6 are the only ones not in F. So then we can look at what's in both, right? In E and in F complement, not in F. So in E and not in F, in both of these is just 6 then. And that would be the only number that is both in E and not touching F. So therefore, the probability, if they asked you, of being in E and not F is 1 element out of 6 total. Now, are E and F mutually exclusive? Okay, mutually exclusive or disjoint means that E and F has a probability of 0. Well, we have E and F is 2 and 4, or the probability of E and F is 2 out of 6. And so no, right? E and F would have to be the empty set. In other words, the set of no numbers if they are mutually exclusive, so that the probability of E and F is 0. So this means probability of E and F is 0. So therefore no, right? And I mean, you could say since B is not what we call the empty set, right? The set of nothing. So we talked about most of these formulas already. Probabilities have to add up to 1. Probabilities can't be negative. And so they can only be between 0 and 1. We can't say the probability is 200 or anything like that. And we talked about this for snow, but in general, probability of E complement, so not in E, is 1 minus that it's in E. And we talked about your inclusion, exclusion, or probably easier to think about as the union. Okay. So in terms of, dependent and independent, if you flip 2 pages to the bottom of 117, if we have replacement versus no replacement, with replacement means that the events are independent. So with replacement means that you replaced and put them back in, right? So with replacement means put the item back in after you take it out. So for example, if I have, a box, and let's say I have 3 pink marbles and 2 green marbles, then the probability I pull out a green right now is 2 green out